Hey everyone, welcome back to Crew's class. In today's video, we'll be looking at an example of locating and classifying the stationary points of a given function. Now in this example, we see the function f of x is equal to 2x cubed minus 3x squared minus 12x plus 4. Now remember, the first thing that we need to do when we're locating stationary points is to differentiate the function. So when we differentiate the function, we get 6x squared minus 6x minus 12, right? So this would be the differential. And after we differentiate the function, we need to then equate it to 0. Because as we know, the differential only occurs, or rather the stationary point, the stationary point only occurs when the differential or the gradient is 0. Now, what we need to do next is solve for the unknown variable x. Now, in this case, it's a quadratic expression, so we would need to factorize it. Now, we see some common terms, 6, and 12, so therefore we can factor out 6 first, just to make it a bit easier to factorize. Now that we have x squared minus x minus 2, we then factorize that term and we have x plus 1 times x minus 2. The 6 will remain out here. It's of no bother to us right now. Now we can solve for x. So if x plus 1 is equal to 0, then x must be equal to negative 1. And if x minus 2 is equal to 0, then x must be equal to positive 2. So we have the two values for x, and now we need to use these values to find their corresponding y values. So we're going to substitute each of these values of x into the original function, f of x. And this function will give us the corresponding y value. So when x is equal to negative 1, we substitute negative 1 everywhere x is into the original function, and we will have this. So negative 1 cubed will be negative 1 times 2, negative 2. Negative 1 squared would be positive 1 times negative 3 will give us negative 3. And negative 1 times negative 12 will give us positive 12. And then we have plus 4. So minus 2, minus 3 plus 12 plus 4 will give us positive 11. So therefore, this would be the y value when x is negative 1. So the first stationary point location will be x as negative 1, y as 11. And we state the coordinate. Now to find the next stationary point, it would be when x is 2. Because remember, the other value for x is 2. So when we substitute 2 into the original function, this is what we end up with. 2 cubes will give us 8. 8 times 2, 16. 2 squared will give us 4. 4 times negative 3, negative 12. And 2 times negative 12 will give us negative 24 plus 4. So we have 16 minus 12 minus 24 plus 4, and will give us negative 16. So therefore, when x is 2, the y value will be negative 16. So therefore, this other stationary point would be 2, negative 16. Remember, x is 2, y is negative 16. So now that we have located both points, meaning that we have found their coordinates, we now need to classify those points as either maximum or minimum. So to classify, we need to find the second differential. So if this is the first differential, we need to differentiate this expression once more, and then we will get the second differential. So it will be 2 times 6, 12x, and it will be, drop off the x, it will just give us negative 6. So the second differential is 12x minus 6. And then what we need to do from there is substitute the x values into this function and to see if it gives us less than 0 or greater than 0. So when we substitute negative 1 into the function, we get 12 times negative 1 minus 6, which will give us negative 18. And negative 18 is less than 0 because it's a negative number. And because it's less than 0, we therefore classify it as a maximum. So at the stationary point negative 1, 11, we will have a maximum point. Now the other x value would be 2. When we substitute 2 into the second differential, we end up with 12 times 2 minus 6, which will give us 24 minus 6, which will give us positive 18. Positive 18 is greater than 0. And because it's greater than 0, we can then classify it as a minimum. So therefore, the stationary point 2, negative 16, would be a minimum. And that is how we locate and classify the stationary points of a given function.